Welcome to This Explainer. Today, we're tackling something pretty amazing. It's one of the most famous, absolutely fascinating mathematical constants out there, pi. I mean, if you've ever stared at a circle and wondered about the hidden math baked right into it, well, you're in the exact right place. Our goal today? We're going to completely demystify this magic circle ratio and give you the ultimate mental toolkit for really understanding it. Let's get into it. So first things first, what exactly is pi? We see this little Greek symbol everywhere in geometry, but what does it actually do? It's this incredibly special number used pretty much exclusively when we're working with circles. But honestly, its true identity? It's something that has literally fascinated mathematicians for centuries. Okay, let's dive into this. At its absolute core, pi is simply a ratio. Think about it like this. If you take any circle at all, and you take its circumference, the full distance running all the way around that outside edge, and you divide it by its diameter, the distance straight across the middle, you get pi every single time. And the really wild thing here, it literally doesn't matter if you're measuring a tiny coin in your pocket or a massive planet out in space, that ratio is locked in perfectly. Section 1. The true value of pi, moving beyond approximations. Right, so in theory, pi is this perfect constant ratio. But in reality, when we actually sit down to solve everyday math problems, we gotta make a choice. We usually use 3.14, or like you see in a lot of textbook questions, 22/7. But what's really interesting about this slide is, neither of these is the exact value of pi. Actually, scratch that, they aren't even close to being the exact value. They are strictly highly practical approximations just to make our lives a bit easier. So what is the actual exact value then? Well, get ready for this. It begins like this, 3.1415926535. And, well, it just keeps going. The actual digits of pi continue forever. No, really, forever. And not only do they stretch out into absolute infinity, but they do it without ever repeating in any fixed pattern. It's just this completely infinite, totally non-repeating sequence of numbers secretly hiding inside the structure of every single simple circle. How crazy is that? Section 2. 3 essential circle formulas, the Class 9 toolkit. Let's shift gears for a second from all this infinite theory to some real practical application. Here are the big 3, the fundamental formulas you absolutely need in your toolkit. Number 1, circumference, where c equals 2 times pi times r. Number 2, area, where a equals pi times r squared. And number 3, diameter, which is just 2 times r. So the crucial point is, if you master these 3 equations, you essentially master the circle. It's the whole shebang. Section 3, step-by-step problem solving, pi in action. Let's just slow down for a second and actually apply this stuff. Say we've got a circle with a diameter of 7 centimeters, right? And we need to find its circumference. Okay, step 1, we identify that our diameter is 7. Step 2, we grab our handy formula, c equals pi times d. Now, because our diameter happens to be a multiple of 7, using the 22/7 fraction for pi is a super strategic move here. We set it up, 22/7 multiplied by 7. And boom, those 7s cancel out beautifully, leaving us with exactly 22 centimeters. And there it is. That is pi in action. Section 4. The big takeaway. Your mental anchor. As we wrap up this explainer, I want to hand you one core concept to really lock into your mind. Pi connects the distance around a circle to the distance across it. And this brilliantly illustrates why pi fundamentally must show up anytime we calculate the circumference or area of any circle. It's kind of like a permanent bridge between the outside edge and the width. If you just remember that specific relationship, I promise you'll never get lost on a geometry problem again. Which, of course, brings us to our final lingering question. Where does pi actually come from, and why exactly is it approximated so well by 22/7? Well, the math goes a whole lot deeper. If you're curious about the true historical origins of pi, or if you're looking for more step-by-step guides to crushing those circle questions, keep that curiosity alive. There's always way more to explore. Thanks so much for joining me on this explainer, and hey, keep learning.